So, first of all, very good evening and welcome everyone in our today's special webinar, which is more like a tech talk. So, myself, Shaboni, and my call sign is VU2 Juliet Foxtrot Charlie, and today I'm representing West Bengal Radio Club. We all are here to mark the 75th Independence Day of India, and we are really honored and happy to have Mr. Ashhar Farhan sir, VU2ESE, the inventor of micro BITX and UBITX among us. We are also happy to recall that he is also one of our lifetime honorary member of our West Bengal Radio Club. Just a little housekeeping before we get started. In case of any query, please feel free to put them in our chat section in Google Meet. And if you are watching us from YouTube streaming, feel free to comment your query there. We will definitely bring them up after the presentation. It's a kind request to all. Kindly mute your microphone in order to avoid any unwanted circumstances. And without further ado, I will hand over the microphone to Farhan sir, who is popularly known as our homebrew hero. Sir has pioneered in developing micro-BITX, UBITX, and has sent satellite to space and started a cultural center named Lamaka Cultural Center. Once again, thank you so much, sir, for your time. And we are really happy and honored to have you today. So now the microphone is all yours. Over to Farhan, sir.
Shaboni and Amrish, thank you so much for having me over today. And it's indeed a pleasure to be here with you all. And I can see that a lot of your members are here. So it's really good. And this is probably the first time that I'm talking about BitX and micro-BitX. And I know that it's going to be a technical talk, but I also know that a number of people here are not very technical people. So I will try, although keeping it technical, but not too technical in the talk now. And my idea would be to actually be able to guide people who would like to build their own radios to build it better, and to also, show where I went wrong and what it took to design not these two specific radios, but to get into homebrewing at all, and what has changed over a long time. So that is how it will be. What I will try doing is I'll try summing up my speech quickly so that we again have time for a round table of sorts where we'll be able to interact with each other and get more questions answered, etc. So Amrish, is that a good format to follow, or would you like me to do something differently?
Yes, sir, actually, we can do that. That will be better, I
All
guess.
right. Okay. So I do not have a presentation, although I will show a couple of slides here and there, just to show some snippets of certain circuits. But this will be more like a talk about, my journey as a home brewer. And I hope that, some of you will find, something of interest here and whatever else, right? So the, the thing is that Indian home brewing is very different from, let's say, home brewing in the United States or Europe, or for that matter, Russia or Japan, etc. Because in all these countries in the developed world, they're getting access to radio equipment is not difficult, especially second-hand equipment is very easily. You can just go and buy it at a hamfest or see it on eBay, etc. Whereas for Indian hams, it has been very difficult and very expensive to always be able to buy equipment. So while in the West the homebrewers homebrewed because they like to homebrew, in India we didn't have a choice. So we actually homebrewed because we wanted to get on air, right? And a lot of homebrewers, you will see that once they have made a set, then they do not actually bother with homebrewing a second set. They're just done with that, then they get on air, they start making contacts, etc. There are few who will just keep on, developing more and more. And I think I'm one of those hams who spend more time on the bench developing radios than operating radios. Although I do operate, I've not been operating for the last week to 2 weeks, but otherwise I do check in the morning nets at least on 40-meter band, and then I get onto CW on 7020, and pick up a couple of contacts. So that's my thing. But when I was a kid, it was almost impossible to, be able to afford uh, a ham radio set. And I still remember that, you know, I was actually mentored by VU2ESE, Suri Garu, and he actually came to our school and did a demonstration. That's how I got interested in this, and then I'd keep visiting his home all the time. And he had this HRO, right, a Second World War radio called HRO, and he had a homebrew AMCW transmitter. So that was the first shack that I saw. And then there was Rajan VU2KNN, who had homebrewed an SSB transmitter, but that too was homebrew, right? So I mean, they all homebrew sets. And then one day, Sadali VU2ST came to Hyderabad for a talk, and he got a radio called Atlas, which was really small. It's about this size, I mean, it was about at the most 8 inches by 8 inches radio. And I was completely blown away because it's the first time actually I'd seen a transceiver work, that the transmit receive everything is in such a small box, and you're able to contact everybody else on the world, across the world, etc. So that actually spurred me to understand transistors better, and I thought that one day I should be able to make a radio like this myself. And what would happen is that the only source of information that we had in those days would be the ARRL handbook, right? So the ARRL handbooks were, it had everything in it, from Morse code, how to learn Morse code, to a couple of designs for SSB radios, etc., etc. But it rushed through everything. There's just one chapter on basics of electronics. There's just one chapter on antenna. So the explanations were not deep enough for anyone to actually read them and understand, although we did try a lot. But the finally, I'll explain to you how we could I mean, we can build radios during the rest of my talk. But the problem that we faced was twofolds. One is there was an urgent need for us to have designs which used a lot of Indian components which could be assembled easily. So if you open an ARL handbook, there were often one or two SSB transceiver designs, but apart from the resistors and some of the capacitors, none of those components were available in India. There was no component which you could buy here, and they were very difficult to get. So what does one do in such a case? I mean, it was completely impossible to do that. On the other hand, buying a ready-made transceiver was also completely out of our budget, especially my budget at least. And the thing was that ham radio was a hobby in which people who were attracted to this hobby were mostly from poor backgrounds, right? I mean, people like me coming from lower middle class, in those days, a house would cost 50,000 rupees and a transceiver would cost 30,000 rupees, right? I mean, if you just want to make the difference. So at such an expensive thing, it was completely impossible for us to afford. And on the other hand, we did not even have the technical expertise. But what happened was that by 70s and early 80s, people were looking at designing radios which others could also replicate. Instead of for example, the SSB transmitter which Rajan built, whatever components he could get from various places, he built this. He couldn't build a second one because those components were not available for the second one. So one such radio ham who was constantly building transceivers and publishing these details was VU2NR, Old Man Raju. And he built actually India's first SSB transmitter, then the first SSB transceiver, and he was building radios on and on, and he actually built a radio called and designed a radio called NR60, which was published by in a newsletter called Spark, which used to be published by, I think it was called Indian Amateur Association or Association of Indian Amateurs, whatever it was, run by VU2IF from Delhi. And that actually gave a PCB and all the coil details, etc. And the NR60 actually became a hot favorite among a lot of us. To be built, it was meant only for 20-meter band because those days 20 meters used to be open every evening and you could do a lot of DXing, etc. So 20 meters was the NR60, and it was called 60 because he built it when he was 60 years old. The problems with NR60 were that they used these coils, which probably I can show you those coils. So, okay. Okay. So this is what that coil would look like, right? So on this, you wound the coil, and you could tune this. And in order to, the problem was of this was that if you had two coils like this side by side, then the signal would jump from this to the other, and that would actually cause instability and would cause the thing to start oscillating. And these were actually used by NR because these were actually VU2NR because these were used in regular shortwave and broadcast radios at that time. So you could actually pull them off them, take out the windings, and then wind it back as required. Actually, I can probably show you the. Let's see if I can. I just pull off my.
Yeah, sorry, he's facing a technical problem, so he will be here soon. Please stand by.
Hello, sorry guys, can you hear me? Hello.
Yes, sir, absolutely fine.
Oh, all right.
Yes, sir. Yes, sir.
Thank you. Sorry, I was trying to present present something, but it's sort of okay. So this here is the NR60. I don't know if you guys can see this, but this is the circuit of the NR60 transceiver. And you see this here, T1, T2, T6, T7. So these are all transformers which are wound on those coils that I just showed to you. And as you can see, it's a very fairly messy circuit diagram. But essentially what he did was that if you see, there are always three transistors here. So one, this is very small, but this is still a transistor. Two, three transistors here. 1, 2, 3, three transistors here. 1, 2, 3, three transistors here. 1, 2, 3, 3 transistors here. So these were actually, this was a discrete version of an IC called C83028, and that's how he built the circuit. So I'll just stop sharing this. Um, I did build this, but it was not a very uh, it, it was not a very easy to build circuit, and winding those coils, getting the um, polarity of the transformers correctly, etc., was very difficult. So that actually did not work for long. And then there was VU2RM's design called RM96, which he had actually designed for to keep in touch with his children, his sons who were doing engineering in Hyderabad. And I unfortunately do not have the circuit diagram for that, but that was also another design which was pretty popular, in the late 90s. And between these two designs, they were good, but they were not of very good quality. And the thing was that, and this is what I'm coming to, is that I was trying to homebrew these things myself, but what I realized is, you solder this entire thing together and you switch it on and it wouldn't work, and you wouldn't know why it's not working, because I had no understanding of what these circuits were doing. So it was very difficult to do that. And in the meantime, I lost interest in ham radio for a long time. I was actually not very keen on radio, and I didn't even have, I was actually living in rented places, so we couldn't even put up an antenna, and eventually my license expired. And Bharti was actually helping me renew the license for a long time, but it was very difficult in those days to get renewal of an expired license. So what changed was that in about year 2002, I had a business in which my friend, who's also Radio Ham, Sugar Mike Zero Mike Fox Charlie, who's in Sweden. So he and I and another friend of ours were running a small business on internet, and I used to go and meet him, twice a year to Sweden. And when I went there, I saw that a new book had come out from ARRL called Experimental Methods in RF Design. It's for short, the book is called EMRFD. Now, what was different about this book, and I have the book here, I'll show you, is that the book said that all radios consist of just 4 circuits, okay? There are filters, there are amplifiers, there are mixers, and there are oscillators. So if you understand how these 4 work, then you'll be able to combine them in various ways and be able to build any kind of radio. So they actually simplified things down to that. That was number one. The most important thing here was that when you build one of these, let's say you build an amplifier or an oscillator, you should be able to measure whether just that is working correctly or not before proceeding to the next stage. So this was a big revelation to me. Earlier, when you see a construction article, it gives a PCB layout and it gives such a big, you saw the NR60 as a layout, right? You have the circuit diagram, you try soldering it all in. Now you don't know whether you've soldered a transistor upside down, downside up, etc. And then you switch it on, if you're lucky, it doesn't blow up. But in all probability, it actually doesn't work. So I have the book here. In fact, I have 2 copies of the book here, and I'll show you why I have 2 copies of this book. So this is the book, right? And here you will see that, I don't know if you'll be able to see that, but there's a chapter on amplifiers, the chapter on filters, the chapter on oscillators, and then you have a chapter on mixers top up here, right, top up here. So, and they gave enough number of pages, 50, 60 pages to each one of them, explaining in detail how each of these blocks work on their own. And the important thing was to be able to know whether something is working properly or not. For example, if you make an oscillator, how do you know whether this oscillator is oscillating at the frequency that you want it to oscillate at? Or if you make an amplifier, how do you know that this amplifier is giving enough gain, or that it's able to amplify at a particular frequency or not? Or when you make a filter, the idea of a filter is that it allows some certain frequencies to pass, signals of certain frequencies to pass through, and stops signals of other frequencies from passing through. So how do you know that it's working well, right? So one of the big things which came out in from this book, which I learned a lot from, was that you have to experiment with this. So for example, if you make an oscillator or an amplifier, you have to feed a signal into it and measure how the signal is coming out from the other end, and you do this to every block. That's number one. Number two is that all these blocks should be able to interconnect with each other in a particular standard way. Now, for example, all our antennas that we build ultimately are 50 ohms impedance, because your radio is also 50 ohms. I mean, your radio's antenna jack is 50 ohms, so it fits in there. But what if all the components that we build were also 50 ohm components, right? So you test each one of them, you make all your test equipment for 50 ohms, and then you go ahead and start building your radios. So that actually is what I did. And the first piece of equipment that I built for this was a frequency counter that I still use. And this is almost about, probably that's the frequency counter. It uses, maybe I can switch it on. Let's see if I can. Okay, here we go. Does it still work? I don't know whether you guys can see, but I think zeros are on here, right? So you can still see that it works. So this is a frequency that I built, and this is a fairly common circuit. It uses a PIC microcontroller. It takes about 2 or 3 days to build this, about 1 hour every evening. Without a PCB, I built this, and if you see, it's been all put inside this case, which is made out of copper-clad board, that is unedged PCB. The reason why I did that was that when you're doing RF testing, it's very important that there should be no RF coming out of this, which will interfere with other RF, right? And it's got a BNC connector. So I built this, and I started using this frequency counter. So with this frequency counter, the next thing that I could do is I could make an oscillator and find out whether that oscillator is oscillating at the right frequency or not. And what I built here was an oscillator like this. So as you'll see here inside this, let me show you. You can see inside it's a fairly simple circuit diagram, a very fairly simple circuit diagram. This is a tuning capacitor from a broadcast set, and as you can see here, there are two sets of coils. There is one coil here and another coil here. So each section here is one oscillator, and from I've taken out the switch for some other purpose, but you could switch between the two oscillators. One oscillator went from about 2 megahertz to 10 megahertz, and the other took from 10 megahertz off to 40 megahertz. So with this, I could actually generate any frequency of any signal of any frequency from here, okay, and I could measure it. If I connected it to the frequency counter, I knew what frequency this was coming out at, right? So I could actually set it to any frequency. Then I disconnected from the frequency counter and feed it to the circuit that I was testing. So that way, what happened is I was now able to test amplifiers, okay? With just the frequency counter, the oscillators could start. So with these, I was able to actually vary the frequency. For example, if I'm making a band pass filter for 7 megahertz, so on the signal generator, as I keep turning it from 4, 5, 6 megahertz, just beyond 6 megahertz, I will see the signal rise at the other side, and then the signal comes down again, and then there should be no signal at 14 megahertz, 15 megahertz, 16 megahertz, etc. So with a combination of the frequency counter, the signal generator, and an RF probe, I was able to experiment with really small circuits, and I will show you some of these circuits here. Let me just see if I can do that. Just do my entire screen share. Okay. So yeah, okay. So I don't know whether you people can see what I'm sharing now. Can you people see the
Yes, sir. Yes,
slide?
sir. Yes, sir.
Okay. Yeah. So you will see in this that there are three circuits. Okay, the circuit on the right is fairly simple. It's just a transistor with which costs about 1 rupee, and there are about 5 6 resistors and about 4 capacitors. There are no coils there at all, and this is an amplifier that you can build in about half an hour's time, just so you can solder this thing up, and into the base you feed the signal generator, and you see how much output is coming at the on the other side, and that way you can know whether this amplifier is working or not. The good thing about this amplifier was that it did not use any coils, so it did not have to be tuned to any particular frequency, right? So that was as simple as that. Now if you see on the top left is a crystal oscillator. Okay, and again very simple circuit, which will oscillate in any case. You can use any transistor here, whether you use a BC547 or a 2N2222, any transistor. You can go to the local market and buy them and build this. Again, in about 15-20 minutes you can build this circuit and see that the output is coming, and you can measure the exact frequency of each of the crystals here with this. So this is a crystal oscillator. Now, the circuit that you see on the bottom, if you look closely, is exactly the same as the circuit on the top, right? So instead of 220 PF, two capacitors, we've just changed the value to 560 PF. And in place of the crystal, I have put up a coil and a number of capacitors. One of the capacitors is a tuning capacitor, the other is fixed capacitor, and the third is a Zener diode, which I'm using as a variable capacitor. So with these three blocks in place, that is, BFO, VFO, and amplifier, you can keep repeating the same circuit diagram over and over again. And this is the circuit of the BITX, the original BITX. Now, if you see that uh, the two transistors which are Q, let me just see what this is. This is Q13 and Q12 are on the transmit side, and the Q1 and the Q2. If you look at all these transistors, Q1, Q2, Q13, Q14, and Q12, Q14, 13, 12, and beyond that 11, all these transistors on the top, right? The top three and the next row of four transistors, they all use exactly the same circuit diagram, right? It's exactly the same circuit diagram. And again, if you see the BFO here, which has this crystal here, which is Q8 and Q9, you will see that it is exactly the same as the Q5 and the Q6, which is the VFO. So once I got one amplifier going, the same amplifier could be used over and over again to do various works, right? And then of course on the bottom you just have an LM386 audio amplifier, etc. But here if you see that the circuit itself looks very simple. It's really a very simple circuit diagram, and it works very well. And there is also a triple tuned band pass filter on the top left, and then you have uh, a pre-driver to drive the power amplifier. I'm not showing you the power amplifier here because that's not very interesting, but what I wanted to show you here was that after having made these three or four kinds of circuits, you can keep using the same over and over again if you know once how well they work. So I would just want to go back to a couple of things which kept changing here. I'll just stop sharing this for a while. Right. So one of the problems with the modern kind of radios which you saw in ARL handbook and EMRFD etc. was that they used toroids. and toroids were just not available in India. So, what does one do? And I thought very hard about it. Then I realized that there are ferrites which are used in TV balloons. So, I'll show you what a balloon looks like. These were actually used in television to convert from the ribbon antenna to the round plug which used to go into the television sets. So let me just see if I can find a balloon. Okay. So this is what the the balloon ferrite would look like. And what I did on this was I wounded a transformer like this, right? And I connected one end of this winding to the signal generator, and the other end I connected to my RF probe, and I went through all the frequencies and I found that it's able to transfer power from one end to another very well, even on HF. So that became a very big thing, a very big breakthrough for me, that one need not wait for toroids, expensive toroids to come from the US, but one could use these here. And I found out that in Delhi they were available for less than 1 rupee each in Chandni Chowk. So when I was in Delhi, I bought actually about a bag of 200, 300 of these. I still have them. I haven't run out of them yet. And with this, I built one radio, which is here. Actually, very few people know about this radio, but it's there on my website called a two-band radio. And I don't know if I can show you this from close by, but you can actually see that I have used these TV balloons in place of toroids. In quite a few places. For example, probably here you can see some of those toroids being used, right? So with this, I was able to build a two-band radio set, which worked on 7 and 14 and ran quite some DX on it, quite some DX, although it just gave about 4 watts of power, but the signals were very clean. And I attribute it to the fact that I was able to uh, make it one stage at a time. So actually, probably I can show you this way. If you can see this, it's okay. Let me actually hold it out. There are quite a few things, new things which I tried here. One is, as you can see, it's built on smaller pieces of boards which are all connected together. This is almost 30, 25 years old. So it's pretty dated, but individual stages are on small copper clad boards, all directly soldered together without a PCB, so that if I make a mistake, I can quickly turn it around. For example, I can show you this as a small board made that way. And the important thing here, one more important thing, was that both RM96 as well as NR60 required you to use an SSB filter, which was available from Bharat Electronics Limited, and they were being manufactured in very small quantities. And one of the writers of the EMRFD, Wes Hayward, he actually came out with a way in which you could build your own crystal filters. Now, traditionally, the SSB crystal filter required 2 sets of crystals. One had to be just 1.5 kilohertz away from the other. So you could buy a 10 megahertz crystal, but you could never buy a 10.0015 megahertz crystal, because they were never actually manufactured that way. So the design of crystal filters by Wes Hayward, which was a ladder crystal filter, was such that you did not require crystals of different frequencies, but crystals of same frequency could be used as a ladder. And that actually opened up homebrewing for a lot of us, because now we did not have to wait for Bharat Electronics Limited or for someone from abroad to get these. And these crystal filters themselves are very expensive, 3,000 rupees per crystal filter. And what we also realized later is that these crystal filters were not even good enough. The Bharat Electronics Limited crystal filters, sorry to say, were not of as high quality as you could make yourself. So once we had our own crystal filters, we did not require toroids for broadband transformers. We could build broadband transceivers, and it became feasible for us to build this, and that's how the the BitX itself started, which was a single band radio set. Now, one more important thing here was the coils. Now, I had mentioned to you that we were using coils
That
like
has to
this,
go this
which
way.
required a shield. And, because what happens is, as I said, that this couples with the coils next to each other. So, what I figured out is that we needed toroids because in a toroid, it's circular. So, as the windings are made around it, the winding on this side and the winding on that side are going opposite to each other. So it sort of cancels the RF uh, radiation from out. The toroid shape is such that there is no radiation coming off the toroid, and most of it remains inside the toroid. At least that's the theory once you have enough number of turns. And we did not have access to toroids at that point. So what I thought is that if I used these things, which are actually used quite frequently in India, inside the water taps, right? So this actually sort of presses in against the wall, which stops the water from leaking in the tap. And they are made out of nylon, and nylon is very good as an RF insulator. So I bought some of these from a shop, and I again wound inductors on this, and I measured the inductances, and I found out that these inductors were pretty good. Although later on I found out that they were not as good as regular toroids, but nevertheless they could be used. So with the Bitex, I used these nylon faucet washers as the toroids. On this I wound the inductors. And with these three innovations, one is the ladder filter, where you could buy some 5 rupee crystals and make ladder filter out of it. Second was using TV balloons as ferrites, and the third was to use tap washers as coils for RF filters. With these three new things in place, we were able to make the Bitex radio, a radio which could be actually built entirely for less than 500 rupees. I have the original Bitex here. I would like to show you that. Sorry, my shack is very. I have pulled it out and I've kept it somewhere and I've forgotten where it is. Oh, here. So, this is the original Bitex. And as you will see here, because I was already confident of how each of the stages work, most of the radios actually built on one board here, and that's the power amplifier. I had a switch for a PTT. This was the transmit receive. This is the fine tuning, and this was the main tuning. As you can see, I have not even marked it yet, and this is the volume control. Very nice set. And the good thing here was, because I was confident of each of these stages working properly, because I had already experimented a lot, the entire radio took about 5 days to from the time I thought of it to the time that I had my first contact. My first contact actually was Mansoor, VU2ESE. And I told him that I just fired this radio and you are my first contact, and he was actually pretty happy about it. I think he was operating from Kodai at that time. So with this, we were able to get this out, and then we went into production. I mean, for a long time, I was actually not interested in producing kits, but what happened was that Dog Hendrix used to run Hendrix kits, and they were making the Bitex 20A, and they closed down, and people internationally did not have a choice of a professionally produced kit. So we got into kitting it ourselves, first for the Lamaka Amateur Radio Convention, and then after that for Indian hams, and then finally for international hams. But there, I realized something. First was that when you're building a kit, and mass assembling these circuits, then the regular resistors, capacitors do not work, because it's very easy to put one in place of the other. So we went with surface mounted devices, and that worked pretty well. Second was we started importing actual toroids, because we could import them in quantities, and we could also order them online now. So Mouser was on, kits and spares, and a lot of other small and big businesses were supporting hams. And the third thing was that we had to put in a lot of testing procedures to start producing the BitX 40. And after the BitX 40, we also came out with micro BitX. But after BitX 40, which was an all analog radio to begin with, there was a lot of demand on us to start producing a radio which could be digitally tuned, which was digitally controlled. And for that, uh, this miracle chip called SI5351 landed up in our lab, and with that we were able to very quickly and cheaply, the chip itself costs $1. So for about a 500 rupees or 600 rupees, you could put a display, an Arduino, and this chip together on a single PCB, which could be used to control any radio. So with that, we moved from being an all analog radio to being a digitally controlled radio. And then came the micro BitX, which was an expanded version of BitX, where we wanted to give multi-band capability. And in order to do that, what we did is that all 0 to 30 megahertz is first converted to 45 megahertz. Because then just a low pass filter is required for you to strip off the image. And from 45 megahertz, we convert to 11 megahertz, and from 11 megahertz, from there on, it's the regular BitX radio. Except that by now, Wes had designed the termination insensitive amplifiers, which are a better form of the amplifiers which were used in the BitX, and we added that onto it, which really improved the voice quality. And subsequent versions of BitX. I'll show you the original BitX as well. So this here is the original BitX which I designed, and you can see even this is designed the same way, using smaller parts, one at a time, tested and put in place. So these are all still usable rigs, although I have not used the original BitX 20 for a long time, but the micro BitX still finds use most of the time. So one very important thing here is been that when you start homebrewing, one thing is to be able to read a book and be able to replicate whatever is in the book or understand the book. But the important thing for me was that I was very lucky to find mentorship and friendship with a lot of other homebrewers who helped me in doing this. So when I was a small kid, I'd go to Andhra Pradesh Amateur Radio Society. This was even before NIR was formed. And there, VU2DEV Dev, whose call sign at that time was RTZ, was sitting there, trying to fix some of the transmitters. And I would just sit next to him and watch him work. And I learned a lot about, even how to proper solder components together. And after that, I met Amrendra, VU2AAP, and we struck a very deep friendship. And during summer holidays, he would often come to Hyderabad, and we would spend days, morning to evening, just sitting and building various circuits. They didn't work because we did not know how to, test individual components, blocks separately, and then again put them all together. But nevertheless, it was very useful experience. But when it came to actually BitX, and one of the key things with BitX is the sort of work that I have borrowed and sort of learned a lot from Wes Hayward W7ZOI, who was one of the chief authors of this book that I was talking about. And about how the circuits probably that you see in the ARL handbook are also due to him. And when I published this on my own website and announced it on a couple of news groups, two hands actually helped popularize this a lot. One of them was Hans Sommer. Hans Summers is Golf Zero United Papa Lima, and he runs now the QRP Labs as well. But he set up the BitX20 group, and he's still an admin. In fact, he's the admin, and I'm not. So he and Arv Evans were two people who actually helped to popularize this design all over the world. And I'm really indebted to them for the efforts that they made. And then the first PCB for this was actually not, I mean, I did design a PCB, but it had a lot of mistakes. But the first PCB which became really popular was designed by Rahul Srivastava, WJM, VU3 WJM. And he actually laid out a very good PCB, which was very stable. And a lot of people in India and abroad started building it, and Sunil Akhani started kitting it as well, etc. And a lot of this information which kept coming out about BitX, and I mean, a lot of people took it and modified it in their own way. The Milton Keynes club in Britain came out with a different version of BitX for 80 meters. Hendrix came out with his own stuff. So there was a lot of information to be disseminated, and there were a lot of exciting things which were happening around the BitX. And one blog called Solder Smokes, which is SOLDERSMOKE, they actually I mean, there are various people who've been part of that podcast, but basically it's run by Bill Miara. So Bill actually built a lot of BitXs. Probably he's built more BitXs than anyone of us. And he has amassed a lot of experience, and he talks about them on his blog as well as on his podcast. And it would be a good idea if you guys can drop into the podcast and start listening to him as well. So, but that's been the story of both BitX and MicroBitX. And with this, I'll stop here. And if there are any questions and all that, I think we have about 15 minutes to take. We'll take these questions, and then we can wind up. Thank you.
Yeah, once again,
Thank you
thank
very much
you.
for answer.
Yeah, sir, once again, thank you so much. Like, it was really great to hear you and your experiences. So, yeah, I will be handovering it to VU3XRY. So, he is also one of our technical heads. So, please go ahead with the questions, VU3XRY.
Thank you, Shavani, for this handover to me, and thank you very much for answer for this wonderful session with you. We are definitely, every one of us has rather gained something from you. There are a few questions which have come up. The first is, what is the difference between VITX, BitX, and UBITX?
Okay, so the BitX it's a single band design. It's very simple. It's a single band design. People can easily make it themselves. The micro BitX is a little more complicated. It's about probably twice as complicated as the BitX, because it covers everything from 80 meters to 10 meters. So those are the differences between the two designs.
All right. The next question is from Sandipan Basumali. It is that currently UBIT is transmitting 5 watt. Any plans to increase the power supply?
So the MicroBitX unfortunately use IRF 510s, and my whole idea of designing the MicroBitX was not to produce it as a kit, but so that people can build it themselves. So I had to go with transistors which were available at that time in the market. And the only transistor which was commonly available in India was the IRF 510, and that's what we have used here. Now, increasing now the MicroBitX on 40 meters can give you about 12 watts of power, and then on 20 meters it gives about 7 watts of power, and on 21 meters it gives 5 watts of power. So actually, as the bands keep going up, the signal keeps dropping. That's because of the nature of IRF 510, and the thing is that you cannot overdrive the 510 because it breaks into self oscillations, etc. So to keep it stable, you have to keep the output level down, and otherwise it will also keep over distorting. So that's how it is. But actually on 40 and 20 meters the power is pretty usable. It's actually more than 5 watts.
Right, so definitely will correct ourselves. And the next question is, sir, is there any plans for incorporating transverter for OQ100?
So Q100 transverter work is going on because it involves a lot of different things. The Lamakan Amateur Duo Club as a club is working on it, and there are 2 transverter designs which are actually, or rather 2 transmitting up converter designs are actually in the works. Both of them are working, but we are still trying to ascertain how good the performance is. And I think in a month or two's time, they will be out.
Okay, sir. These are the few simple questions to you. And now I'll hand over this session to Shaboni once again. Shaboni, please take this session.
Yeah, sir. So after your session, you have covered a lot and we have heard a lot from you. So now I would like to hand over it to you to JFA, Mr. Ambrish, to convey his vote of thanks. And if anyone else has any more doubt or query, can also put up in the comment section. We will also look into that. So mic over to you to Juliet Foxtrot Alpha.
Okay.
Thank you, Farhan sir. Thank you, everybody, participant who are in this Google Meet and who are also watching our YouTube channel. We are very much happy that Farhan sir, this is his first time sharing his experience. Moreover, we are just looking his shack live. It is our great opportunity that Farhan sir shows his shack to all of us. Thank you, Farhan sir, and thank you for your live member of West Bengal Radio Club. We will send you shortly our another memento to you that at the time of Hamfest, we are not able to arrange our good memento for you. We are prepared a good memento, your honorary live membership. Yes, sir. I will send you immediately. Yes. Yes, sir. Yes, sir. Thank you so much. Thank you so much, sir. We are very much happy that you are keeping in. We are very much happy to see you in this evening. We will take help again. We will sure that you will definitely meet with us in this technical session. In each every week, end of week, we are arrange this type of technical session with our academy student. We have an academy, Indian Academy of Communication and Disaster Management. So many students is here. They will ask so many questions to you, to your email, sir. Hope we will answer them. And we will immediately purchase some UBITX set for our club station, sir. And we have also organized some workshop, already organized some workshop, and definitely organize so many workshop in future and need your help, sir. Thank you so much in this evening, and happy pre-independence day to you and everybody listening this session. Thank you so much, sir. Hope you will better. You said, Sabuni, take microphone.
Yeah, sir, once again, thank you so much for your time, and it was really great to hear you and all your experiences. So definitely, we hope to learn more from you in the coming future. So cannot hear you.
All right.
Sir, can I
three, and it was, yeah, sure. Go ahead.
Sir, actually, there are few questions which have come up in the YouTube live streaming.
Okay.
The first one is, could RPI replace Arduino for BITX, for UBITX and BITX? Understand?
Sorry.
The BITX could have.
Can you repeat the question again?
The question was, could RPI replace Arduino for UBITX and BITX?
Yeah, you could do that, but the Raspberry Pi, I think that's what you mean by RPI, is sort of an overkill for this. It actually consumes a lot of power and it requires a different kind of a display, etc. But people have done that, and we actually now my new radio, which is right now being designed, is based on Raspberry Pi. It's a software-defined radio. So I've already spoken about that at the 4 Days in May conference, which happened in May, and probably by next month I'll release all the details of this. I mean, some details are already out there on the internet.
And the next question was asked by Vic Uniform 3 Tango Quebec Delta. He asked that, can you please throw some light on USDR and your upcoming projects on this?
Okay, USDR, I'm not too sure because I have not built one. And as I said that, unless I build something myself and try it out, it's very difficult for me to comment on how good or bad it is. But the USDX, for one, it's got a lot of people interested in SDR, and it's a very simple design. Uh, I hope it works very well because if something that simple can work and provide us with QSOs and contacts, it would be a really good thing. Um, the SDR that I'm working on is a high-end SDR, which is a little unfortunate, but it's very interesting because Raspberry Pi is in the circuit itself. So, for example, you can run FT8 mode without requiring a computer. You can you can do logging, you can do a lot of other things, you can run the DX clusters, etc. So all the software for which you required a computer can now be run inside your radio itself. And that's the advantage of the SBitX which I'm doing. Um, the USDX, again, I'll just come back to that, which is written by, I mean, it's basically a new software for Hans Summers QCX radio, actually, right? So it's built on that. Uh, it's very cleverly written. So I think it's just worth your while to experiment with it, to play with it, to modify it, because it's very easy to do. It's just Arduino based. You don't have to learn anything more with it, and it can actually provide you a lot of educational, you know, um, with a lot of education with and a platform where you can try various things. And at the end of the day, if the Arduino doesn't work, you can take it out and replace it with something else. So that is an option that you always have with this. Any other questions?
Okay, sir. Thank you very much. No, sir. No more questions. I would now I would give this session to Shaboni for the closing.
Okay, so once again, I'm back, and thanks to everyone for your time. And we had many attenders who have watched our live streaming via YouTube and also via Google Meet. And thank you once again, sir, for being here. So, as of now, we are shutting down today's session, and it was really great. And we are really honored once again to have Farhan sir among us. So, once again, Independence Day greetings to all. Jai Hind and 7th Goodbye.
Oh, by 73